For 70 years, American outboards ruled the water. Mercury, Yamaha. Names that meant power. Names that meant victory. But right now, in quiet labs across Europe, engineers are building engines that burn half the fuel, last twice as long, and deliver more torque than anything flying the American flag. One Swedish diesel saved a commercial fleet $150,000 in a single year. A Norwegian electric hit 50 knots, faster than any battery-powered boat before it. And a British engine, born from a tragedy at sea, now runs on 22 different fuels, including jet fuel. The American giants didn't see them coming. Tonight, we reveal the 10 European outboards so efficient, they're rewriting the rules of marine power. And by the end of this video, you'll understand why some of the smartest boaters in the world are quietly making the switch, before everyone else catches on. To understand why European outboards now threaten to reshape the marine industry, you first have to understand how completely American manufacturers dominated it. The story begins in 1939 in a small Wisconsin town called Fond du Lac. A young engineer named Carl Kiekhaefer bought a failing outboard motor company for a few $1,000s. He renamed it Mercury Marine. Within 2 decades, that company would capture a commanding share of the American outboard market, built on a simple promise: power and reliability. By the 1960s, Mercury had become synonymous with performance, racing victories, dealer networks stretching across every coastal town, a brand that recreational boaters trusted with their weekends and commercial operators trusted with their livelihoods. When Americans thought about outboards, they thought about Mercury, but Mercury wasn't alone. The outboard wars of the 20th century featured fierce competition. Evinrude, founded in 1907 by a Norwegian immigrant, pioneered two-stroke technology and battled Mercury for market supremacy for generations. Yamaha entered the fray in the 1960s, bringing Japanese precision engineering. Honda followed, emphasizing fuel-efficient four-strokes. For decades, these brands fought for every percentage point of market share. Then came the horsepower arms race. In 2004, Mercury launched the Verado line, supercharged four-stroke outboards with computer-controlled shifting and joystick piloting. The message was clear. This wasn't your grandfather's outboard. This was aerospace engineering bolted to a boat transom. Competitors scrambled to respond. Yamaha answered with the XTO 425 in 2017, claiming the title of most powerful production outboard. Mercury fired back in 2019 with a supercharged 450 horsepower V8. And then, in 2021, Mercury dropped what it called its masterpiece, the Verado V12. 600 horsepower, twin turbos, a price tag exceeding $70,000 per engine. Luxury boat manufacturers lined up for allocation. Industry magazines declared it a revolution. But here's what the glossy advertisements didn't emphasize: that V12, at wide-open throttle, drinks fuel at a rate that would make a commercial airline nervous. We're talking 60, 70, even 80 gallons per hour depending on the application. Run it for a weekend of offshore fishing, and you've burned through more fuel than most sedans use in a month. The math gets uncomfortable quickly. A typical 300 horsepower gasoline outboard consumes roughly 20 to 25 gallons per hour at cruising speed. Over 500 operating hours, a reasonable estimate for an active recreational boater across several seasons. That's 10,000 to 12,000 gallons of gasoline. At current fuel prices, you're looking at $35,000 to $45,000 just in fuel. Before you pay for maintenance, winterization, or the inevitable repairs. For commercial operators running boats 1,000 hours per year or more, fuel bills can exceed $80,000 annually. Per boat. American manufacturers knew these numbers, of course, but their calculus was straightforward. Horsepower sells boats. Efficiency doesn't make magazine covers. If customers wanted to save fuel, they could simply slow down. This philosophy worked beautifully. As long as fuel stayed relatively affordable, regulations remained lax, and no one offered a serious alternative. But while American engineers focused on cramming more cylinders and more boost into ever larger powerheads, something different was happening across the Atlantic. In Sweden, a team of naval veterans and automotive engineers began asking a dangerous question. What if efficiency was the real performance metric? In Germany, a company called Torqeedo started selling electric outboards years before Tesla made electric vehicles mainstream. In England, aerospace engineers who had survived a boat fire started designing a diesel outboard specifically to beat gasoline at its own game. The quiet revolution had begun. And American manufacturers, focused on their horsepower wars, barely noticed. The first engine that should worry American executives sits in a factory in Ängelholm, Sweden, a small coastal town. Population 30,000. Not exactly the place you'd expect to find technology that threatens a multi-billion-dollar industry. But that's where Simco Marine built the Oxy 300. The team behind it reads like a thriller novel cast. Naval high-speed boat operators, automotive engineers who'd worked on supercars, technicians who understood what happens when equipment fails in rough seas. Starting in 2012, they set out to build something the marine industry said couldn't be done: a high-performance diesel outboard that could match gasoline on speed while crushing it on efficiency. Their secret weapon was a BMW inline-six diesel engine, mounted horizontally inside the cowling. But the real innovation came below the waterline. Instead of traditional bevel gears and drive shafts, Oxy engineers developed a patented belt drive system that eliminates nearly a third of typical drivetrain losses. The result? 945 Newton-meters of torque at the propeller shaft. Numbers, as the company puts it, previously unheard of in the outboard industry. One commercial operator running twin Oxy 300s on a power catamaran calculated his annual fuel savings at $150,000 compared to equivalent Yamaha gasoline outboards. That's not marketing spin. That's operational accounting. Across the North Sea, in a small English town called Shoreham by Sea, another team was building something equally ambitious. Cox Marine began with tragedy. In 1967, a boat fire in Greece nearly killed the family of a man named Charles Good. The culprit was gasoline: volatile, flammable, unforgiving. Good spent decades searching for a safer way to power boats. Eventually, he partnered with engineer David Cox and assembled a team of aerospace veterans to build the world's first purpose-designed diesel outboard. The Cox 350 V8 isn't an adapted car engine stuffed into an outboard housing. It was engineered from scratch specifically for marine use. A 4.4-liter twin-turbocharged V8, the largest block in the outboard industry. 350 horsepower, 650 Newton-meters of torque, in the sweet spot between 2,200 and 3,000 RPM. And here's what makes military procurement officers pay attention. It runs on 22 approved fuels, including JP5 jet fuel, meaning vessels can eliminate gasoline entirely. Cox set the diesel outboard world speed record. Production began in early 2025. The order book is filling with Coast Guards, navies, and commercial operators who've been waiting decades for exactly this engine. But diesel wasn't the only revolution brewing in Europe. In Florø, Norway, a fishing town on the western coast, a startup called Evoy asked an even more radical question. What if electric could be fast? Not golf cart fast, not trolling motor fast, genuinely, exhilaratingly fast. Their answer was the Storm 300 Plus, 300 horsepower of continuous electric output, an 800-volt architecture, the only system of its kind in the marine industry, and a partnership with Finnish boat builder Axopar that produced a prototype capable of 50 knots. That's faster than any electric boat most industry observers had ever seen tested. The Storm achieves this with just 4 moving parts. A traditional combustion outboard has more than 2,000. Fewer parts means less maintenance, fewer failure points, and dramatically lower operating costs over the engine's lifetime. Meanwhile, in Bavaria, a company called Torqeedo had been proving electric's viability for nearly 2 decades. Founded in 2005 near Munich, Torqeedo sold its 100,000th electric outboard by 2020. They partnered with BMW to marinize electric car batteries. Their Deep Blue systems now power everything from small tenders to 34-meter superyachts. In 2024, Yamaha acquired Torqeedo. The message was unmistakable. Even the giants recognize that European electric technology represents the future. In Kiel, Germany, engineers at Neander Motors approach diesel efficiency like Swiss watchmakers approach timepieces. Every component scrutinized. Every inefficiency is eliminated. The result was the Detorque 111, the world's smallest common rail diesel outboard and perhaps the most elegantly engineered small marine engine ever built. The Detorque produces just 50 horsepower. On paper, that sounds modest. But the specifications tell a different story. 111 Newton-meters of torque at 2,500 RPM, performance that outstrips 70 horsepower gasoline outboards across most of the operating range. The secret lies in Neander's patented dual counter-rotating crankshaft design, branded the Spaceball system. Two crankshafts spinning in opposite directions cancel out the vibrations that would normally make a small two-cylinder diesel unbearable to operate. The engine burns 10 to 12 liters per hour at full throttle. That's roughly half what comparable gasoline outboards consume. Expected lifespan exceeds 10,000 hours, double the typical gasoline engine. Yanmar, the Japanese diesel giant, recognized the Detorque's potential immediately and partnered with Neander for global distribution through 5,000 service centers in 130 countries. For harbor patrol boats, water taxis, fish farm tenders, and superyacht chase boats, the Detorque represents something American manufacturers simply don't offer: a small, efficient, virtually indestructible diesel option. But efficiency gains from better engines tell only part of the story. In Stockholm, a company called Candela asked a more fundamental question. What if the problem isn't the engine at all? What if the problem is the hull? Every conventional boat, no matter how powerful its outboard, fights the same battle against physics: water resistance, drag. The faster you push a hull through water, the more energy you waste shoving liquid out of the way. At planning speeds, even the most efficient engine loses most of its power to hydrodynamic friction. Candela's solution was radical: eliminate the water contact almost entirely. Their boats rise on computer-controlled hydrofoils, lifting the hull clear of the surface until less than 1% of the vessel touches water. The foils adjust 100 times per second, responding to waves, wind, and weight distribution. The result cuts energy consumption by 80% compared to conventional boats. Powering this flying machine is the Candela Seapod, a torpedo-shaped underwater motor with dual counter-rotating propellers delivering 50 kilowatts in a 50-kilogram package. That's 4 times the power density of other marine powertrains. No gears, no transmission, no oil changes. Direct electric drive with efficiency numbers that make traditional outboards look prehistoric. In 2023, a Candela C8 traveled 483 miles in 24 hours, charging during brief dock stops. Total electricity cost: 110 euros. The equivalent journey in a conventional boat would have burned 1,400 euros in fuel. Candela now sells electric hydrofoil ferries to cities from Stockholm to the Maldives. They're not just building efficient engines, they're proving the entire American propulsion philosophy: push heavy hulls through water with brute force, may be obsolete. Supporting these innovators is an industrial ecosystem that American manufacturers lack. Italy's Selva Marine, operating since 1945 near the Swiss border, provides the manufacturing backbone. They're the official supplier to the Italian Coast Guard and production partner for Torqeedo, Neander, and Seven Marine. In Austria, Steyr Motors supplies diesel power plants engineered for 10,000-hour lifespans. This is the European model: specialized companies collaborating across borders, sharing expertise, building components that integrate into complete systems. No single company tries to do everything. Each focuses on what it does best. The result is an arsenal of efficiency technology that didn't exist a decade ago. Diesel outboards that halve fuel consumption, electric systems that eliminate it entirely, hydrofoils that reduce energy needs by 80%. And American manufacturers? They were busy adding more horsepower. The question isn't whether American manufacturers see the threat. They do. The question is whether they can respond fast enough. Consider Mercury's position. 32% of the American outboard market, thousands of dealers. Factories tool for gasoline engine production. A workforce trained on internal combustion. A supply chain optimized for pistons, crankshafts, and fuel injectors. Every one of these assets, built over 80 years, becomes a liability when the market shifts toward diesel and electric. This is the legacy trap. The same infrastructure that made Mercury dominant now makes pivoting extraordinarily difficult. You can't retrain a dealer network overnight. You can't retool factories in a fiscal quarter. And you certainly can't abandon the gasoline engines that still generate the profits funding any transition. Mercury's electric response has been the Avator line, launched at the Consumer Electronics Show in 2023. The first model, the Avator 7.5e, delivers roughly 1 kilowatt of power. Subsequent releases have scaled up to the 110e, equivalent to approximately 15 horsepower. These are capable products for auxiliary applications: dinghies, small sailboats, calm water fishing. But compare that to Evoy's 300 horsepower Storm, already powering Axopar sport boats to 50 knots. Or Torqeedo's Deep Blue systems pushing super yachts. Mercury's electric lineup, as of today, maxes out at roughly 5% of what European competitors offer. That's not a gap, that's a canyon. The regulatory environment makes catching up even harder. In Europe, the Recreational Craft Directive Stage 2 standards have forced manufacturers to meet strict emissions limits for years. European engineers didn't innovate around efficiency because they wanted to. They innovated because regulations demanded it. Meeting RCD2 wasn't optional. Either you solved the engineering problem or you exited the market. American regulations have historically been gentler. But that's changing. EPA Tier 3 standards are tightening emissions, requirements for commercial marine engines. California's air quality mandates increasingly push commercial operators towards zero-emission solutions. Military procurement policies now frequently require diesel-only vessels, eliminating volatile gasoline from ships entirely. When regulations tighten, the companies with compliant products win contracts. The companies still developing prototypes watch from the sidelines. The commercial sector is already defecting. The United States Coast Guard, the largest maritime law enforcement agency in the world, began trialing Aux-E diesel outboards in 2017 through a cooperative research and development agreement. When your own Coast Guard tests European engines because domestic manufacturers don't offer acceptable alternatives, that's not a market signal. That's an alarm. The Philippines Coast Guard recently ordered 40 high-speed vessels equipped with 80 Aux-E 300 diesel outboards. Ring Power Corporation, a major American industrial equipment distributor, expanded its Cox Marine territory to cover Florida, Georgia, the Carolinas, and Bermuda. These aren't European companies selling to European customers. These are European companies capturing American and allied military markets. Commercial operators are doing similar math. Norwegian salmon farming giant Bremnes Seashore converted workboats to Evoy electric power and calculated their savings. Their technical leader put it simply: the boats work perfectly, maintenance disappeared, and the only thing crews need to remember is plugging them in at night. Fish farms, wind turbine service vessels, harbor operations, and water taxis run boats over 1,000 hours annually. At that utilization rate, fuel efficiency isn't a preference. It's the difference between profit and loss. European manufacturers understood this years ago. They built products specifically for customers who count every gallon. American manufacturers built products for customers who count horsepower. For decades, that worked. Horsepower sold boats. Efficiency was an afterthought. But fuel prices rise, regulations tighten, commercial operators sharpen their pencils, and slowly, then suddenly, the customers who once accepted inefficiency start asking harder questions. The race is now openly acknowledged. American manufacturers are investing billions in electrification and alternative propulsion. The question is whether investment translates into competitive products before European companies cement their lead. Mercury's parent company, Brunswick Corporation, has made electric propulsion a strategic priority. The Avator line will expand. Partnerships with battery technology firms are accelerating development timelines. Industry analysts expect higher-powered Mercury electric outboards within the next few years, but development cycles in marine propulsion typically span half a decade or more. Evoy and Torqeedo aren't waiting. Yamaha's acquisition of Torqeedo in 2024 represents the most direct response to the European challenge. By purchasing the pioneering German electric company outright, Yamaha instantly gained 2 decades of electric propulsion expertise, a proven product lineup, and access to BMW battery technology. Beginning in 2025, Torqeedo outboards became available through Yamaha dealer networks across 8 European countries. This is significant. Yamaha's distribution muscle combined with Torqeedo's engineering could accelerate electric adoption faster than any startup could achieve alone. But integration takes time. Corporate cultures must merge. Product roadmaps must align. Meanwhile, competitors like Evoy continue launching new models and signing partnerships with prestigious boat builders. Honda and Suzuki are pursuing incremental improvements. 2% fuel efficiency gains here, enhanced corrosion resistance there. These refinements matter for loyal customers upgrading within familiar brands, but incremental improvement cannot close a fundamental technology gap. You don't catch a competitor who's running by walking slightly faster. The market data suggests a tipping point approaching. Industry analysts project the marine outboard market will grow from roughly $9 billion in 2025 to nearly $12 billion by 2030. Within that growth, electric propulsion represents the fastest expanding segment. 24% of prospective buyers now express interest in electric outboards. 39% of American boat owners cite efficiency and noise as primary purchase criteria, not horsepower, not top speed. Commercial and government sectors are shifting even faster. Military procurement increasingly mandates diesel-only vessels. Coast Guards worldwide are evaluating European diesel and electric options. Fish farms and harbor operations, where boats run thousands of hours annually, are converting fleets to European technology because the economics are irresistible. The next decade will likely reshape market leadership in ways not seen since the outboard wars of the mid-20th century. For the American boater watching this, the implications are practical. Fuel costs are not decreasing. Resale values will increasingly favor efficient engines as buyers grow more sophisticated. Dealer networks for European brands are expanding across North America. The engine that represents the smartest purchase today may not wear the most familiar badge. For the marine industry, the implications are existential. Manufacturers who dismiss European competition as niche or irrelevant are making the same mistake Detroit automakers made when they dismissed Japanese imports in the 1970s. Small, efficient, and reliable eventually becomes the standard. The companies that recognize this first will lead. The companies that recognize it last will follow, or disappear. Engineering, ultimately, is not about building the biggest machine. It's about building the best solution. For decades, American manufacturers defined best as most powerful. European engineers defined it as most efficient. Both definitions produced remarkable technology. But only one definition aligns with a future of rising fuel costs, tightening regulations, and customers who increasingly care about operating expenses and environmental impact. The American giants are not destroyed. Their resources remain vast. Their engineering talent remains formidable. Their dealer networks remain unmatched in North America. But for the first time in 70 years, they are not leading. They are chasing. And in an industry where product development cycles span years, chasing is a dangerous position. The European outboards you've seen tonight represent more than competition. They represent a different philosophy of marine propulsion, one that may prove better suited to the century ahead. What you do with that knowledge is up to you.